So in my first week of computer architecture for the summer, we're in this MOBA-X term, and we are actually using our professor's library while we're coding. So I'm going to first log into here, and then it's going to just load, and after it loads, it'll give this. I am just going to clear it, that way we can have a blank space, and what we're going to do is go into a file, and to make a file or to go into a file that we have to do nano and then the actual file name itself. So we're going to do nano, and then I'm just going to do lab.asm because I'm going to be working on my first lab. So I go in here, I don't have anything in here because I erased everything so that I can rewrite it. So in assembly here, a comment, instead of being two backslashes, is just a hashtag or a pound. So we're going to call it lab1.s, and then we will have name here, and then after this we'll have another pound, and then after this we can start writing our instructions. And this is basically how we're going to run it. So to assemble our code, we're going to say assemble, and this is going to be as-o, and then we need lab1.o, and then we need lab1.asm. We need the o before the asm, and we're going to do this after we exit out of this nano when we're done writing it. And then to link our code to the professor's actual library, we're going to need to do link, and we're going to call ld for link that, and we're going to do -o lab1.o, and then we also need csc35.o because that is the library name. Should be csc35.o. And then to execute our program, we are just going to write ./a.out, and after we do this, it will execute our program. So now we need to start writing our code. We're going to use the Intel format. There's Intel and AT&T format, but Intel is, I guess, more standard, so we're going to use that. We need to use .intel lower slash, and then we're going to do syntax, and then we have to say no prefix. So this is going to be the first line. And this, we can just write a comment, and we're going to just say that this is using Intel format. So we'll come all the way over here, hashtag, and we'll say use Intel format. So that's commented out. Then we're going to go on to the next line, and we're going to do .data, and we are basically starting the data section. We can't do starting, it underlines it in blue like this, so it probably means it actually does something. So we'll just write start. That way it looks more formal. And then now under here, we can actually start writing our what's equivalent to kind of like methods, because we're going to call this later in our code. So we need a title for something, and we're going to basically create a address, and then we are going to put something in our address. So we're going to create our hello world, and that is going to be our greeting. So we have to use greeting, and this is going to be our title name, and then we can go in here for spaces, and to store something in here we have to do .ascii and then quotation marks. We'll do hello and then comma world, and to go to a new line we're just going to do /n, and to end this, instead of using a semicolon, we're going to do /0, and that'll end the line. And what this is doing is it is creating a buffer for ASCII, and then in our buffer we're just going to be printing this name right here. If I wanted to print out my name, I can just make a title for it. It could be anything we want. We're just gonna have to remember this later to call it, so it should be something relative to what we're putting in here. We're gonna do name, and then we have to use .ascii to type in it, our quotation marks, and then a /n, and then a /0. And then before this, we're just going to write our name. So let's write name here. We can write this like this. so there's spacing for it. So after I print my name, if I wanted to have a quote in here, I can just write quote, and this is going to print the buffer for ASCII, and then we're going to have dot ASCII, and then same format where we have these two quotation marks, a new line, and then the ending part, and then in here we'll have our quote. And after we write out our quote, we can just do a /n and then 0. So we could actually put all of this in one line. We could do the same thing for the next, where we would actually combine it in the line, but this is going to be part of a different thing where we actually print an integer as well as our string. So I'm going to push these closer so that we can start doing our code. So we can do year 1 is what I'm going to call it, and then we're going to have a .ASCII in here with the string in the year, and then a /0, because we're going to continue this line in our next part. So we don't want to make a new line, so we're just going to end the line with a /0. Next, we're going to have year 2, and this is just basically the next part of this string. We need to separate it because in the middle of it we're going to have a integer. So we're going to have .ASCII, and then we're going to print out we're going to get the year, and we're going to print out the integer in between this, and then we're going to use the year 2010, and we're going to say in the year 2010 Tesla went public, and then a period /n, and then we're going to end this line with a 0. Now I'm just going to put the comments here. Now that we have written all of our comments down, we can move on to the next part. So we have all of our strings here. This is all of the strings that we need to use later. So now we're going to go on to the second part. In the second part, we're going to actually print our text, so we're going to have to use .text. And since we're calling these globally, we're going to have to use .global, and then a space, and then underline, and then start. So what text does is it starts the text section. And what global start does is it makes the _start label public. So we have a global start, we have our text, and then before we start writing our code, we're going to have to do one last thing, which is do an underscore or an underline start, colon, and then we are going to be able to start calling our stuff. The way we're going to call this is by using LEA, and what LEA means is we are loading the effective address. So we're basically loading this into our program. We're saying LEA RAX greeting. So what we're doing is we are basically loading our greeting, which we have here. We're loading it into REX, and then we're going to call the print C string. And when we call the print C string, it's going to print out our RAX. So we're loading greeting into RAX, and then we are printing out the C string. So this is going to print out our hello world. And then after this, we're going to do the same thing but for our name. So we do LEA RAX. We're going to do name. This is case sensitive, so that's important. We're going to call the print C string to print it out. The C and the P and the S need to all be capitalized. So after we print out name, we want to print out our quote. So we're going to do the LEA. We are going to call our quote. So we're going to have to do quote, and then we are going to have to call the print C string. So we'll do call print C and then string. After we do this, we want to start now with our year. So we're going to have LEA RAX and then year 1, and then we're going to need to print this. So we're going to do a print C string, and this will print this first part. Now we want to put an actual year in here because we have in the year, and then we don't have anything, and then we have this next part. We also actually need a space in front of Tesla so that our year will not be right next to the T. After we have this, which is also why we have a space right here. And then after we have this, we can actually call the print integer. So to print an integer, we are just going to put the integer in there ourselves. So we're going to have to use the move. So we're using move, and then we're going to move our integer into RAX. So we're going to have our integer, which is 2010, and we're moving it into RAX So we're going to have RAX like this, and then comma in 2010. Just like the load effective address right here, we are taking our greeting, putting it into RAX, and then we are calling print cstring to print it out. However, in here, we are loading our 2010 into RAX, and instead of calling a print cstring, we need to do something a little bit different, where instead we call print int. And this is how we can print the actual integer. So we're going to print the integer by using this call print int once we've stored our 2010 into RAX. Now we want to print out the second part of our year 2 to finish our code. So we're going to say LEA because we need to call the second part, RAX because we're storing it in here temporarily, and we're just going to say year 2. So we're storing year 2 into RAX, and then we just need to print this out. So we're going to do print c string, and this print should be capitalized. Once we have all of this, all that we need to do is just end the program. So when we're done with all of this, we can just write call end program. And what this will do is just call and kill the program. So now that we have all of this done and written out, we can go over it. So all of these are just comments talking about the lab title, the name, and how we assemble it, how we link the files from my professor's library to mine, to my code, and then how to execute it. Then we do Intel syntax no prefix, which uses the Intel format, and then we do .data, which starts the data section. Next, we have all of these, and each of these titles that are followed by a colon is going to create a buffer for ASCII. And in our ASCII, we are just going to have a string, and we are just going to call it later in our program. When we're done with our data section, we're going to go into a .text section. We're going to do .global. This needs to be spelled correctly, so it's global. And then super important, where we have a space right here, where we need a space between global and the underscore for start. Then we do underscore start, colons, and then we have everything that we're printing. And we have all of our comments correctly right here for every single line. So the start is the Unix start, and then we have to call LEA RAX greeting. We are calling load effective address, and basically we are putting the address into RAX. So I changed the comments a little bit to say load effective address because that's what it's actually doing. It's not putting it, it's loading the address into RAX. So it's loading this address of greeting, and it's loading what we've stored in greeting. So it's going to load this, and it's going to store it in RAX. And then we're going to call print string to print it out. We're going to do the same for the rest of these. What we do here is we print this out, but we don't have a new line in year, or we shouldn't have a new line in year. So I'm actually going to take this out. We shouldn't have a new line in here because on the same line, we are going to want to print out this move where we call print in, and then the rest of the string. So we're going to say in the year 2010, Tesla went public. So we have a call print this part, which is going to print out the year 1 address. And then after this, in here, in this .text part, we are putting 2010 into RAX using the move. We're basically moving 2010 into RAX, and then we're calling print in to print it out. And then we are loading the effective address to print out year 2, or to load year 2 into RAX, and then we're calling print C string to print it out. After we do that, we are ending the program. To get out of this, we're going to do Control X, press Y to save, and press enter to get out of here. We're going to clear all that, and once we have this, we need to type in what we need to do to run our program. So we're going to assemble it first, which is as-o, and then we need to do our title, which is lab1.o, and then we need to follow that up with a lab1.asm. We're going to press enter. If there's no text following this, that means there's no errors. So we're going to do ld for link that. We're going to do -o. We need to do lab1.o, and we actually need to do a.out, lab1.o, and then we need to do we need to do csc35.o. This first line is assembling our code, and then this second line is linking the a.out to the actual code of our lab1, and then the library from the professor. And then if we press enter, we have an error. It says in function start we have undefined reference to greeting. So we need to go back into the code to actually fix this. We're just going to use the up arrow to go to nano lab 1 ASM, and then we're going to go in here to run it, or to fix our code. So I'm actually going to fix this comment because we need to do an a.out here, and it looks like we had an issue with a starting part right here. The reason we have an error here is because I misspelled greeting in the second part. It should be GRETT. Once we have this as well, we can Control X for exit, and then press Y to save, and press enter to go back into here. So we've fixed this error. So that means if we use up arrow to assemble it, and I'm actually going to type this out, it'll be AS-O, and then our lab title, which is lab1.o, and then we need to do lab1.asm. It's important we get this order right, otherwise we will overwrite what we wrote, and that would not be good. So no errors here, and we're going to do link that, and we're going to link it to a.out. We are going to link a.out to our lab1.o, and then we're going to link this to our csc35.o. Once we enter this, we see we have no errors, so we should be able to output this freely. We are going to assemble it, and we're going to call it, and we're going to use a.out. Press enter, and then we see that we have our text, hello world. We have my name is name. We have our quote, and then we have our string with our integer in the middle. So this output right here is the result of our code from the part that we wrote in here. And this was the first lab for computer assembly.